So yesterday we talked about parallelograms. And what did we learn about parallelograms? What makes a parallelogram? Opposite sides are parallel, right? Okay? And what else is true about parallelograms? Opposite sides are congruent, right? What were you going to say? Opposite angles are congruent. Good. Okay, they're supplementary. So your consecutive angles are supplementary. Good. What if you have one right angle? Then they're all right. Good. What did we learn about the diagonals? They bisect each other. They intersect each other at their midpoint. What if you just draw one diagonal? What happens? It cuts it into two congruent triangles, right? Okay, good. And it does. It would cut it in half. Not exactly where you could fold it in half, but yes. Okay. So today what we're going to do is kind of work backwards. And we're going to say, okay, well, we have this quadrilateral. How can I prove it is a parallelogram? What kind of test does it have to pass? Okay, there's 5 different ones that you can test to see if it's a parallelogram. Okay, and if it meets one of those, then it's a parallelogram. The first one is to use the definition. Okay, if you can show that the opposite sides are parallel, then you have a parallelogram. And it could be as simple as, let's say, they told you that this was 100 and this was 80, and let's say this was 100. Okay? If I look at these top 2 angles, they're supplementary, right? Those are consecutive interior angles. That makes these 2 lines parallel. And I look at these 2 on the side, those are supplementary. It means these 2 are parallel. Okay, so that would be one way that you could show that you had parallel lines, just by looking at those angle measures. But what if you were given coordinates? If I gave you ordered pairs for each one of these vertices, what would you have to show in order to show that the lines were parallel? The slope, right? So you would have to show that the opposite sides have the same slope. Okay, and remember your slope formula. Y2 minus Y1 over X2 minus X1. Okay, the second test that you can look at is to show whether or not the opposite sides were congruent to each other. Okay? If you were told that this side was 6, this side was 6, this side was 5, and that side was 5, then that's sufficient enough information to show that that's a parallelogram because opposite sides are congruent. But what about, instead of giving you that, let's say I gave you ordered pairs again for each one of your vertices. What would I have to look at in order to determine the distance, right? So I would have to show that these 2 have the same distance and that the other pair of sides have the same distance. So you would have to show opposite sides are the same using the distance formula. And remember your distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So I'd have to do that for all 4 sides and show that the 2 opposite each other were the same. The third way is just to show that the opposite angles are congruent. Okay? Let's say that this was 110, and this is 70, and this is 70. Well, these are obviously the same, right? And what's the sum of all the angles of a quadrilateral? 360, right? So I could add these 3 together and subtract from 360, and I would find out that this was 110. And so if I did that, my opposite angles are congruent to each other. And so it's a parallelogram. Probably wouldn't have to mess with if I gave you coordinates. That wouldn't be an option to do it that way. Okay, the fourth way is to look at the diagonals and to show that they bisect each other. Okay? Let's say that I say this was 6, this was 6, this was 3, and this was 3. If you were given that information, then you could say that this was a parallelogram because the diagonals bisect each other. But what again if I gave you coordinates for the vertices? What would you have to look at in order to determine if it was a parallelogram? Okay, you would have to look at the midpoint of both diagonals. Okay, it has to be the diagonal. And if you can show that both diagonals have the same midpoint, then it's going to be a parallelogram. So you would show both diagonals have the same midpoint. And remember, your midpoint formula gives you an ordered pair. You add your x's together, and you divide by 2, and you add your y's together, and you divide by 2. And they would have to be the same for both diagonals. And then the last one, this is one that's kind of different than what we talked about yesterday. All these other kind of correspond with what we talked about yesterday. But this is a little bit different test. And in this one, if you can show that one pair of opposite sides are both parallel and congruent. So you pick a pair of sides and see these are both parallel and they're both congruent. That would be sufficient enough information to say this was a parallelogram. Okay? But what if I gave you coordinates again? What would I have to use? Use the distance formula to show that those are the same and slope. Okay? So you would have to show one pair of opposite sides parallel using slope and congruent using the distance formula. So 5 different tests that we could do. Okay? We can show opposite sides parallel, that's using the slope, or the angle measure, depends on what you're given. Show opposite sides congruent, might have to use the distance formula. Opposite angles congruent, the diagonals bisect each other. And last, one pair of opposite sides both parallel and congruent. Those are our 5 tests. Alright, so let's look at this proof here, it's a little hard one. It says that triangle ABD is congruent to triangle CDB, and I want to show that ABCD is a parallelogram. Well, what can I get from the fact that these two triangles are congruent that's going to help me prove that this is a parallelogram? What do you think? What do I know if I had congruent triangles? John?
BC is congruent to AB.
Okay, those two sides are going to be congruent to each other, right? What about the other pair of sides? They're going to be congruent also. Okay, and what reason am I going to use there? CPCTC, because I've got congruent triangles, right? So all their corresponding parts are congruent. So these two are congruent, and these two are congruent by CPCTC. And so if I establish that, then what do I know about the quadrilateral? Is it a parallelogram? Why? Because opposite sides are congruent, right? Okay, so let's write that down. Triangle ABD is congruent to triangle CDB. That's given. And then we want to say that BC is congruent to DA, and BA is congruent to DC. And we said that was by CPCTC. So now I've established that opposite sides are congruent. I can say that ABCD is a parallelogram. And the theorem really is this: if a quadrilateral has opposite sides that are congruent, then the quadrilateral is a parallelogram. So I'm going to write that whole thing out. So you can just put opposite sides congruent. That'd be sufficient. Okay, here's a couple more. It's not a proof, but you just kind of have to look at it and justify it. Look at A. It shows that FG and JH are both 14. What does that tell me? They're congruent, right? Okay. Now, it says that angle G is 100 and angle H is 80. How does that help me? They're what? They're supplementary, okay? And so if I have consecutive angles that are supplementary, what can I do from that? lines are parallel. Remember, if you have two lines cut by a transversal and your consecutive interior angles are supplementary, then your lines are parallel. So that's what I have going on right here. So these two are parallel. So is this a parallelogram? Yes. And the reason is you have one pair of opposite sides, both parallel and congruent. Okay, what about this next one? Is this one a parallelogram? I've got three angles here. Can I find this fourth one? Yes, what is it going to be? 65, because the sum of all the angles is 360. So if I add these together and subtract from 360, I'm going to get this is 65. So then how can I say that this is a parallelogram? The opposite angles are congruent. So my answer would be yes. Opposite angles are congruent. Could I have used opposite sides parallel? Could I have done that? If I got rid of that 65, aren't these supplementary? So then these would be parallel, right? These are supplementary also, right? So these two would be parallel. So I could have used that reason too. I could have used opposite sides parallel. Okay, so either one of those. All right, what about C? What do you think? No? Okay, that's correct. Why? There's really not enough information. I have one pair of opposite angles congruent, but I really don't know necessarily that these are congruent, do I? I don't know that these are supplementary, and I just have one pair of sides that are congruent. So there's really not enough information here for me to determine that. So I just have to assume that it's not a parallelogram. All right, any questions before we go to the next page? Okay. I like these. Maybe three. So find x and y so that each quadrilateral is a parallelogram. What is going to have to happen in order for this to be a parallelogram? The opposite sides need to be congruent to each other, right? So I'm going to figure out what x is and what y is in order to make that happen. So I'm going to set 6x minus 12 equal to 2x plus 36. And then I'm also going to set 4y equal to 6y minus 42. And I'm going to solve for x and for y. So I'm going to bring the 2x over. That gives me 4x. Add 12 to both sides. That gives me 48. Divide both sides by 4, and x is going to be 12. Then I'm going to solve this one. Move the 6x over. That gives me negative 2y equals negative 42. And then I'm going to divide both sides by negative 2, and y is equal to a positive 21. So if x is 12 and y is 21, we have ourselves a parallelogram, okay? What about this one? What's going to have to happen here? It's giving me information about the diagonals. What has to happen with the diagonals? They have to have the same midpoint, which means they have to bisect each other. And when you bisect each other, you break each other into two equal parts. So these two parts are going to have to be congruent as well as these two. So again, I'm going to set myself up two equations. And I'm going to set 5y equal to 2y plus 12 and x equal to 5x minus 28. We're going to solve. Alright, so I'm going to subtract 2y from both sides. That gives me 3y equals 12. So y is 4. And then I'm going to subtract 5x from both sides. That gives me negative 4x equals a negative 28. And so x is 7. So if y is 4 and x is 7, again, we have ourselves a parallelogram. Okay, because the diagonals bisect each other. Alright, so that was fun, right? Okay, way more fun than this next one. Not my favorite, I'll be honest with you. It's kind of like cleaning the toilet. Okay, nobody likes to do it, but it's got to be done, right? Or it's gross, yes, we just got to do it, okay? They're kind of long and yucky, but you guys aren't smart enough, I know, to do it. It's not hard, it's just long. determine whether the figure with the given vertices is a parallelogram. Use the method indicated. Alright, so we have this quadrilateral here, and we want to determine or show or verify that it is a parallelogram. So we have A, B, C, D, and they want us to use the slope formula. You have to use whatever method they tell you to use, okay? Alright, so if I'm going to use the slope formula, what am I going to have to use to verify this? What am I going to have to do? What do you think, Reese? How am I going to use the slope formula and show that this is a parallelogram?
Subtract the y's, put it over the difference of the x's.
Right, I'm going to use the slope formula, but what is my goal? What am I trying to show? I got to show that the slopes are the same, right? For both pairs of opposite sides, right? Okay, so let's do that. I'm going to start out with AB and CD, okay? So I'm going to find the slope of AB. And again, you're going to subtract the y's and then subtract the x's and put one bottom. So I got 3 minus 2 over 3 minus 8. That gives me a negative 1/5. Then I want to find the slope of CD. And I have to do negative 1 minus 0 over 6 minus 1, which is a negative 1/5. So are those two parallel? Yes, AD is parallel to CD. Okay, AD is parallel to CD. Okay, now I have to look at the other pair of sides. Okay, and that would be AD and BC. Okay, so now I gotta look at the slope of AD. And if you guys like to stack them on top of each other and subtract that way, that's fine. It'll work, it just takes a little longer. Which is fine, as long as you're right. So AD, I have to do 3 minus 0 over 3 minus 1. That gives me 3 over 2. Then I would do the slope of BC, and that would be 2 minus a negative 1 over 8 minus 6, which is 3 over 2. So are those parallel? Yes, they have the same slope. So AD is parallel to BC. So is this a parallelogram? Yes, why? Opposite sides are parallel. So ABCD is a parallelogram because opposite sides are parallel. Alright, we got one more. That one was so much fun, we're going to do another one, right? This one, same scenario, they give us 4 coordinates. This is P, Q, R, and S. And they want us to use the distance and the slope formula. Which one of those tests require us to use both distance and slope? The last one, right? So you have to pick one pair of sides, right? And show that they're the same length and they have the same slope, right? Okay, so we're going to pick one pair of sides. Let's pick PQ and RS. Okay? So PQ and RS. And I'm going to have to show they have the same slope, and I have to show they have the same distance. So let's do slope first. I like to do slope first because if slope doesn't work, I don't have to mess with distance, right? Usually the slope works on these, but hey, you never know. Alright, so I want the slope of PQ. And again, you subtract your y, 3 minus a negative 5 over, subtract your x's, 5 minus 1. That gives me 8 over 4, which is 2. Okay. Then I want to look at the slope of RS. And again, I'm going to subtract the y's. And then I'm going to subtract the x's, negative 6 minus a negative 2. That gives me negative 8 over negative 4, which is equal to 2. So are those parallel? Alright. So PQ is these do everybody's favorite formula, right? The distance formula, because we want to see that they're the same length. So I want to find the length of PQ. And remember on the distance formula, you subtract your x's and squares. So 5 minus 1 quantity squared plus 3 minus a negative 5 quantity squared. That gives me 4 squared plus 8 squared, which is 16 plus 64, which is the square root of 80. Okay, one more time. This time I gotta find the length of RS. And so I have to subtract my x's, negative 6 minus a negative 2 quantity squared plus negative 1 minus 7 quantity squared. So that gives me negative 4 squared plus negative 8 squared, which is 16 plus 64, which is the square root of 80. So are they the same length? Yes. BQ is congruent to RS. So is this guy a parallelogram? Huh? Yes. BQ RS is a parallelogram because one pair of opposite sides is both parallel and congruent. I had to do this 5 times, but you gotta only do it once, huh? Okay, so what are the 5 tests? Show what? So the opposite sides are parallel and you might have to use slopes, right? How else? Opposite sides congruent, you might have to use distance, okay? What else? Opposite angles congruent, okay? What else? Diagonals have to bisect each other, which means they intersect at the midpoint, which means you might have to use the midpoint formula, okay? And then the last one pair of sides, parallel and congruent, which means you have to use distance and slope, okay? All right, that's it. Any questions? Nope. All right, your assignment is on page 417.